A solution to a system of equations is any point that makes both equations true. So for example, I might ask, is 2 comma 3 a solution to y equals 4x minus 5, y equals minus 2x plus 1? Yes or no question. You got a 50-50 chance of being right.
Yes.
And your answer would be yes. Why do you say yes?
Because if you plug the 3 for y and the x in for 2, they both solve.
All right, so let's try it. If I plug the 2 in for x for this first equation, I get 4 times 2. That's 8. 8 minus 5 is 3. So it works for the first one. Plug it in the second one. What's negative 2 times 2? Negative 4 plus 1 is negative 3. So is it a solution? No, it worked for one, but it did not work for the other. It's got to work for both. So the answer would be no. All right. How about the point? Hopefully one of these is the right answer. I'm just copying out of the book here. How about 1, negative 1? Is 1, negative 1 a solution to that system of equations?
Yes.
Yes. You sure this time?
Yes, I'm sure.
Yeah, you're sure this time. All right. If I take x equals 1 and I plug it in, I get 4 minus 5. 4 minus 5 is? Negative 1. So it works in the first one. If I plug 1 into the second one, I get negative 2 times 1, which is negative 2. Negative 2 plus 1 is? Negative 1. So it works in both. So the answer would be yes, that is the solution. Now, the question is, other than just guessing, how do you come up with that answer? Yeah, but what if I didn't tell you to try 1 comma negative 1? How would you guess to get that right answer?
Did you find them or something? Or?
Actually, kind of, but that's not what we're going to do today. What we're going to do today to solve is we're going to do what's called solve by graphing.
Can you move that up?
Yep, I'll move it up. So let's say I gave you these two equations, y equals 4x minus 5 and y equals negative 2x plus 1, and I asked you to graph both of them. Now it helps if you have graph paper, so you can draw nice accurate graphs. Unfortunately, I didn't bring the graph paper with me today, so I'll just do my best. How would you graph the equation y equals 4x minus 5?
Plot the y-intercept at negative 5.
Plot the y-intercept at 0 comma negative 5. 1, 2, 3, 4, 5. And then what?
Up 4 over 1.
I use my slope. I would go up 4 over 1. So if I go up 4 and over 1.
Can you move that up a little?
Better? So that puts me, where's that point right there? That's 1 comma negative 1. Because I started at negative 5 and I went up 4. So that puts me at negative 1. And then I went to the right one. Alright, so there's the first line. It's supposed to be a line. Not very straight. You get the idea though. How would you graph y equals negative 2x plus 1?
Same way, right? Set the y at 1.
Pretty much the same way. Start at your y-intercept, 0 comma 1. And then you would go down to over 1. We happen to hit right there. So when I ask you for the answer, when I ask you what's the solution, what are we really looking for?
Where they intersect.
Where they cross. That's exactly right. We're looking for where those two lines cross. Where do those two lines cross? They cross at 1, -1. So our answer would be 1, comma, -1.
Is there a term for the point where they cross?
The point of intersection,
Point of intersection.
or the solution. It's also called the solution. Other questions? All right, let's try another one. How about y equals -1/2 x plus 3 and y equals 1/3 x plus 8. All right, we draw our grid. Make it nice and big because I'm going to need lots of room. How would you graph the first one? Y-intercept is 0, 3. And then go down 1 over 2. So what point is that right there?
2.
That's the point, 2, comma 2. And I connect my dots with a nice straight line. I want to use something to make a straight line here. What do I have? Piece of paper, maybe. It helps if your lines are straight. Why does it help if your lines are straight?
I have a ruler.
That would be too easy. Thank you. It helps if your lines are straight because you really want to see where they're going to cross. If your lines aren't straight, then it might not look like the right spot where they cross. So as I say, it's really helpful to have graph paper in this section. Really helpful to draw your lines straight. All right, the second one. Y-intercept is at 8. 2, 3, 4, 5, 6, 7, 8. And then my slope tells me to go up 1 over 3. 1, 2, 3. So that's the point.
9, 3.
Other way around, 3, comma 9.
Oh, 3 comma 9.
And I draw that line. Could extend this first one. So, where do they cross?
They don't all do it use its way.
They do, but it's way over here somewhere, isn't it?
-5, 6.
All right, so it looks like it's about 1, 2, 3, 4, 5, 6 up. Now notice they didn't cross right on one of my lines. They should have, probably. How come they didn't? They didn't use graphing paper, so I don't know that, especially these spaces this way. I went 1, 2. I don't really know that that one's 3. So I've got to kind of guess here and hope I can find the right answer. This looks like the y value is 6. And how about the x value?
-5.
-5? I wouldn't guess -5. I think I would guess -6 if I were going to guess. Why would I guess -6 and not -5? Although both of those look reasonable. -5 looks reasonable. Why do I think -6 is a better guess?
But it's in between.
No?
Because it's like a factor of 3 and 2.
Because if I plug in -6, it's going to cancel the fraction there. And if I plug in -6, it's going to cancel the fraction there. So that's my guess, is it's probably -6. Could it be -5? Sure, it could be. But I'm hoping that the author was nice and set it up so that the answers don't come out to be ugly fractions. So let's find out if that works. Let's plug in x equals -6. What's -1/2 times -6? 3, and 3 plus 3 happens to be 6, so it worked for that one. And then I plug in -6 here. 1/3 times -6 is -2, and -2 plus 8 is 6. So, I did happen to guess the right answer. But you can see why in this section it's very important to draw accurate graphs. If you don't draw accurate graphs, your answers could be off, and you might not have the right answer. What would I do if negative 6 comma 6 wasn't the right answer?
Try something else.
I'd have to try something else. Yeah. Or get graph paper and draw a better graph and be more sure. Okay? So watch out for that. Graph paper is going to be very important in this section. And on the test, I will give you graphing grids to use, but you might want to have a ruler with you or something. Use your calculator, something to draw the line straight. All right, how about this one? I don't see one exactly like I want. Yeah, I'll try this one. X plus 4y equals 20. 2x minus 4y equals negative 8. What would you do to graph the first line? X plus 4y equals 20. You want to get y all by itself? Okay. So I got to do some work then, don't I? X plus 4y equals 20. What would you do to get the y all by itself? Subtract x. 4y equals minus x plus 20. Then divide by 4. And when I divide by 4, I need to make sure I do it everywhere. So I would write it as y equals minus 1/4 x plus 5. So now I graph. My y-intercept is 5, 0, 5, right there. And then my slope tells me to go down 1 over 4. So that's going to be the point 4 comma 4. Use the ruler again. All right, very good so far. How about the second line? 2x minus 4y equals negative 8. How would you graph that? I have to get y by itself? I don't think I have to. I think I can, but I think there's actually a better way. So this goes way back. We did graphing a long time ago. Here's what I would do to graph the second line, and it's what I actually would have done to draw the first line also. What I would do is I would just find the intercepts. So I would plug 0 in for x. If I plug 0 in for x, 2 times 0 is going to be 0. That piece is going to go away. So how do you get the y all by itself? Divide by negative 4. So you'd have 2. So I would have 0 comma 2. Oops, you can't see that far over, can you? So I just plugged 0 in for x, makes that piece go away, get y all by itself. Then I would switch it. I would plug 0 in for y. When I plug 0 in for y, that part goes away. X has to be
Negative 4.
negative 4. My opinion is that's much, much easier than getting y all by itself. Is it wrong to get y all by itself? Of course not. But when y is not all by itself, I think it's a lot easier to just find the two intercepts to draw the graph. So now I have 0, 2 and negative 4, 0. And I play connect the dots. Where does it look like they cross? Certainly looks like they cross at 4, 4. Am I sure that's the right answer?
Yeah, plug them in C.
A good idea is to plug them into C. I don't really need to plug 4, 4 into the first equation, because I already know it works for the first equation, right? Because that's one of the points we drew when we drew our line. So I would take 4, 4 and plug it into the second one. If I plug 4 in, I get 8. minus 16. Is 8 minus 16 equal to negative 8? It is. So 4, 4 is the right answer. Questions on that? All right, 2 more problems I want to do. How about, I'll just make them up and I'll see anything because one's in the book that I like. Two x plus 3y equals 6, and y equals negative 3 halves x minus 1. That's not what I want. Sorry. I want negative 2/3 x. We'll see y in a minute. Negative 2/3 x minus 1.
Can you just real quick go over how you did the 2x minus 4y equals negative 8 on the next one, like you made the little table?
Yep, I'm going to do the exact same one on this, exact same thing on this problem. So we'll see it again here. So what I would notice for the first equation is y all by itself? No. Could I get y all by itself? I could if I want to, but my opinion is that's too much work. So when I see an equation like this where y is not all by itself, all I do is I draw a little table and then I plug 0 in for x. What happens when you plug 0 in for x? The 2x goes away. So you're left with 3y equals 6. You divide both sides by 3. Y is 2. So that gives me the y-intercept. And then I switch it and I find the x-intercept. To find the x-intercept, I plug 0 in for my y number. What happens when I plug 0 in for my y number? I get x is 3. That's exactly right. 2x equals 6. So x has to be 3. So I have 0, 2. And 3, 0. Okay, so that's my opinion. My opinion is I don't like to do all the algebra to get y all by itself. I just like to plug in the number 0. So I do. And I find plugging in the number 0 to be a very easy thing to do.
And then once you get that, you plug in 0 for x and you get the y, and you can plug in 0 for y.
And get the x, correct. Compute the 2 intercepts. Now, the second one does have y all by itself. So that one I like a lot. That one I go to my intercept. That's 0, comma, negative 1. And then I would go
Down to the right 3?
down to right 3. And I connect the 2 lines, the 2 dots.
Parallel each other?
Those 2 lines are parallel. That's exactly right. So where do they cross? They don't. So what's the answer?
No solution?
There is no solution. And that can happen. Sometimes 2 lines are parallel. So our answer here would be no solution. The fancy math word that you will see is inconsistent.
Which one would you prefer on the test?
On the test, I will accept either one.
If you put undefined, would that be okay or no?
Not really. Undefined is not really correct. When you go to do your homework on MyLab, when you go to do your quiz on MyLab, it will say solve the system or show that it's inconsistent. So that will be one of your buttons to pick. So you need to understand that inconsistent means parallel, means no solution. When you go to take your test, if you write no solution, that'll be fine with me. Questions on that? All right, here's the other weird thing that can happen. Well, we'll stick with the same line, 2x plus 3y equals 2, equals 6, I mean. But my second line is going to be y equals minus 2/3 x plus 2. Once again, to draw the first one, it's the exact same problem we had last time, but again, I would build a little table and I would find the intercepts. Plugging in 0 for x, I still get y as 2. 0 for y gives me x as 3. 0, comma 2, 3, comma 0. Don't give away my secrets. But you're right. The second line has a y-intercept of 0, comma 2, which is right there. And then the slope tells me go down 2 and over 3, which is right there. What do I get? In fact, I get more than 2 solutions.
Infinite.
I get one there and I get one there, but I also get a solution there and one there and one there and one there and one there. I get an infinite number of solutions. What can you tell me about those 2 lines?
The same.
They're really exactly the same lines, aren't they? Just written different ways. And that can happen. So your answer here will be infinite number of solutions. Or the fancy math word that you will see is dependent. So again, when you go to do your homework on MyLab, the directions will be solve the system, or show the system is inconsistent, or show the system is dependent. And so you need to recognize what inconsistent and dependent mean. Inconsistent means parallel. Dependent means one on top of the other exactly the same. Michael?
So, kind of means that like that one on top of the other?
Yeah, dependent means
Like I thought you said, like there's an infinite
wait, there are an infinite number of solutions because those 2 lines cross at every spot on the line, don't they? They're really exactly the same line. So 0, comma 2 is an answer. 3, comma 0 is an answer. That point right there, whatever it is, it's an answer. That point right there, it's an answer. There's a lot of answers. So that's what dependent means. Dependent means there are an infinite number of answers, or it means they're really exactly the same 2 lines. Nothing different about them. Questions on that?